Okay, the mandatory slide on the speaker background, So when I put together this slide and I said, what can I tell about my career? I think one thing I can confidently say is that I've always followed my curiosity. And so that began with my disciplinary training as an environmental economist. After that, the PhD at that time was about decision-making under uncertainty as related to climate change, and increasing sea level rise in the Chesapeake Bay. After that, I worked briefly at the University of Minnesota, so this is kind of like coming back to your workplace. And I was a Sloan Foundation funded early researcher with the Food Industry Center. And at that time, my research topics, which was all around food and the food industry, related to health and terrorism, the economics of health on one side and terrorism on the other side. It was around in 2011 that I recognized that the world was going online, and I was like, I know nothing about how to think through measurement when it comes to the online world. And that was the interest that took me to Target, where I actually stayed on for 10 long years, a decade, doing different functions. Target's big, and we do different kinds of things in different corners. But my joke at that time was like, when I started at Target, I went in as an analyst. By the time I was coming out, data science had come on as a profession, so I came out as a data scientist, So I joined as an analyst, came out as a data scientist. Target was heavily focused on digital and omni-channel analytics. And finally, in 2021, I was one of those great reset moments of COVID, asking a lot of questions about what do I want to do with my life. And by that time in my career, I think I had some perspectives on how to be a tech leader, based on my own experiences. And I'm like, I'm ready to go out and try this. And so when Ovative came looking, I signed up with Ovative. I do have a slide of Ovative, but that's my very last slide, because I'd really want to bring you into the world of like what I do as an applied data scientist in marketing. But at Ovative, I lead a team that's known as Strategic Projects. It's a data science and engineering team. And the whole goal of the team is to be so rapid in its prototyping of emerging capabilities that we can quickly bring it onto the market as offerings, leading to the monetization around those offerings. Okay. So the outline for this talk, of course, my goal, as you can see, is to bring you into what a career as an applied marketing data scientist can feel like. It is basically around marketing measurement. So I have 3 sections in which I'm going to organize the talk. The first is bring you into the world of some of the methods that are very exclusive to the world of marketing. Second, I want to comment about the data. Marketing data is unique in its own way. And then I do want to talk about how AI, mostly focused on the assistance part of it, how AI is changing how we work as data scientists in this industry. So on to methods. So the first thing I want to discuss in the methods, it's something that you probably heard of, if you've ever looked at methods in marketing. It's called the marketing mix models. It's like a lot of MMMs. That's how we refer to it. MMMs, not to be mistaken with the chocolate, like MMMs. It is the foundational approach that is used to measure and optimize marketing effectiveness. So at the heart, it is traditionally a statistical analysis technique that is used by the marketers to estimate the impact of various marketing tactics, primarily on sales. Your KPIs or the key performance indicators or the outcome variables can be a wide range, but most MMMs really focus on sales, explaining sales in a company, like how much is marketing driving the sales for that company. The model results helps business understand how different elements of the marketing mix contribute to this key outcome, allowing for some data-driven decision-making and marketing investment optimization. Overall, looking at this slide, as you can see, the structure is very, very similar to any other predictive modeling you could do. You would have to collect your data, you will have to clean it up and do all kinds of exploratory data analysis around it. Then you have to analyze it, and then the outputs of the model has to go into some downstream application. In this case, it becomes the budgeting and the forecasting to understand the nuances of the return against your marketing investment. A brief slide. It's a very dense slide, but this is the evolution of the MMM through the ages. It actually got introduced very early on in the 1950s, but it was more of a thought process. Through the 1980s until 2010, I think it got more sophistication in its methods. Big companies started using it more for their understanding, for their marketing, and for their budgeting decisions. But I think the big change really started coming around 2000. Compute started going up, became more accessible and easy. 2010s, by the time, my journey in joining Target to learn more around the digital world, the online retailers coming on, the social media platforms coming on, they kind of changed how marketing was working. Previous to that, it was a newspaper, it was a magazine article, but you had all of those ad inserts. You had television, and you had commercial on televisions. But this change that we saw on the digital side kind of brought advertising out of newspapers, out of television, and put it on your social media networks. It put it on Google. You could say, hey, I'm searching for a pair of shoes, and it will give you all the kinds of shoes that you can buy and all of that. So that fundamentally changed how the data evolution started happening, who had the data, and how the MMM started evolving. I also think somewhere between 2000 and 2010s is when, thanks to the compute, the Bayesian implosion happened, And so a lot of the MMMs began to change from being very in-house frequentist to Bayesian, because now you could have access to a lot more compute and you could do some Bayesian regressions run. There was also the privacy concerns, all around the data. And so basically all of the regulation, the gated, the big players, led to what we are experiencing in 2020s. It's not just the adoption of MMMs at many company levels. What's happening in 2020s is, rather than being it something like a gated behind a vendor or a provider, MMMs have gone open source. So with all the big tech players who had to defend all of the money they were asking you to spend on these big advertising platforms, they came up. So Google came up with its Meridian, Meta came up with its Robin, and then there's also the passionate, not attached to a big tech company, the PyMC group, very probabilistic regression analytics group. They came out with their PyMC MMM. So what we saw and what we are experiencing in the 2020s is this explosion of open source MMMs. So just a stat, that comes from some of the intelligence we study at the company. 61% or more of any marketer who spends more than 500K are actually looking for a MMM that's faster and that's transparent. And that prompts these more and more people engaging with the open source MMM to fulfill that need. As I said, previous to the open source, there were companies who were in-house building these models and then were taking it to different companies and selling them. What open source did was democratize that, because now any company can ask, tell me how you build this model. Tell me what assumptions you have in this model. Tell me how I'm supposed to be using it. And so that empowered. I listed again, I did forget to mention there's Uber too, and there's Orbit, and just as MMMs have become democratized, what Amazon is coming into the market right now is not yet fully open source or democratized. It's kind of gated. But if you're an Amazon subscriber, you can actually go into their systems and you can start to see what they are developing in-house or bring your own kind of models into it. Why it matters, and of course you can tell I'm giving this talk on open source MMMs that I lean very heavily into, personally myself, into open source MMMs. But what it allows for is very fast experimentation, right? So think of the world in which you have to write every single line of code. Of course, AI might change that, with how it's changing the game. You have this ready-made code set, and you can experiment faster, and you can understand, well, what happens if I change this? What happens? So your learning is so much faster in that. As I said, it's an open collaboration. So you're not just dependent on the know-how of the people within your company. You are a part of a community of methodologists, and that's spanning the globe. So I have methodologists in North America, methodologists in Europe. They're all contributing to these open shared libraries. So you get to and there is Discord and Facebook and lots of forums in which you can go and ask questions. So you're not alone in how you're using this or how you're developing this or contributing to this. And I think it also allows for like confident causal inference, because if you had just had one model, you would question, did I get this right? Is everything is coming? But now when you have 3-4 model choices and you can run the same data set through it, it just opens up that space for you to be more confident. Like, I know this is happening. It's agreeing across no matter which modeling technique I'm taking and not. One thing I want to say is that I don't want anybody to get the impression that, oh, open source is just easy breezy, just do it, It takes a lot of training and understanding as a practitioner of MMM to really leverage these free code bases correctly and for the right problems that you have. And I'm very, very, very privileged and blessed in being in a company that also runs the advertising, has a ton of marketing expertise, to make sense of like, hey, I saw this in the model. Does this check out? Does this make sense? Like with the business stakeholders that I have. Okay. A bit more. This is me trying to give you a illustration of what exactly we put in MMMs. MMMs, as I said, is like literally essentially about attribution, the measure, of the media's impact on your KPIs like sales, customers, lead generation. The maroon part is the media only. You could do an MMM that ignores everything else and it's just about the media mix, or you could do a more comprehensive MMM in which you will not only be looking at advertising, but other factors, with some of which are under the control of the advertiser, some which are not. Just to give you a flavor, I think there are certain key elements that a MMM has to nail, for it to be a self-respecting MMM. The first is time. Of course, this is about explaining those KPIs over time. You can have big promotional movements, you can have big marketing moments. So like time, you have to get 9. And this is where, if you ever taken textbookish, time series, all your awareness of time series has to come into play, because at any moment looking at that sales, which is essentially like a time series, you have to figure out what is the seasonality in the data, what is the trend in the data, how are holidays impacting the explanation of the model. Holidays are very painful, seasonality and holidays, because I believe they become one of the confounding sources, because most companies will run their promotions at the most seasonal times of the year. So like as a data scientist, to parse out the attribution between like, oh, this is the amount that goes to seasonality, and this is the amount that's because it was Christmas Day or Black Friday Day, and this is the amount that is only because of, it becomes a challenge, like parsing it all together apart. The other aspect of MMMs, which is very exclusive to marketing, is ad stock, So like ad stock is literally the advertising stock that persists over time. So here is the notion in marketing theory that says that if you were to watch an ad today, like global, YouTube or something, it's not like you're buying it right away, right? Like whatever it was. So you are going to be remembering it, and somewhere in your memory, that brand will stick. And then maybe a few weeks down, maybe a few days down or weeks, depending on like the ad stock, how long it persists, it will actually influence a purchase. So this is what we mean by ad stock, like the persistence of the advertising effect over time. And this will vary by the channel in which you are consuming the advertisement. The second aspect of marketing is something we call the diminishing marginal returns, or saturation or response curves, So this is the theory that says, you cannot infinitely spend on marketing. There will be a time when the marketing is not linear anymore in your spend. The returns from marketing is not linear. It will be plateauing off. And this is the response curve, So initially when you're spending, you will get good returns against your spend. But after a point of inflection, it becomes a flat. In fact, it can diminish too. So this is what we call the response curve, or the diminishing marginal returns curve. And your model must both adhere to ad stock effects as well as this notion of diminishing marginal returns. When it comes to algorithmic choices that you can put in doing this model, a constraint comes from the fact that marketing effect can at the minimum be 0, but it cannot be negative. I personally have questioned this a couple of times. This was given to me as I became an applied data scientist, because I can think of a couple of episodes in the last few years where, the marketing has gone wrong and has actually resulted in negative sales for a company. But till date, like that is one of the theorems of marketing theory that will say that you can at most be zero, but you cannot be negative. What it does is it puts kind of constraints on the algorithms that you can bring forward. So, and regular, ordinary least square or linear regression, like OList kind will not work because you will have to prevent your coefficients from getting into the negative zone. And so here is kind of my very quick comparison of what each of these open source solution gives us versus does not give us. The first is from Meta, Robin MMMs. They are the frequentist, okay? Although they're the frequentist, essentially they are ridge regression, part of penalized regressions that will prevent your coefficients from going to below zero. What Meta does behind the scene is it's not just one run of a frequentist model. They actually allow you to go over what we call the hyperparameter space and turn a lot of models. So there is a system called iterations, and you can run as many iterations with different values of some of the hyperparameters. And at the end, it floats up the top model by something known as the Pareto optimality criteria. So ridge regression paired up with Nevergrad, which is Meta's proprietary algorithm for running this very fast for you, is the frequentist version, the only frequentist version of the MMMs that we have. Time series, it uses Meta's developed Prophet for ad stock. It has geometric and Weeble kind of saturation. It is something that is known as the Hill function. Almost every open source out there uses the Hill function for when it comes to the diminishing marginal returns of the response curve. Next is Google's Meridian. That is actually a Bayesian one, and you can see it which kinds of infrastructure it uses. It's MCMC. For those, I won't go into too much of details, but it's the kind of sampling that they use, and they use something that the TensorFlow system that Google has developed themselves. As I said, it's Bayesian, it's time series Bayesian. In model classes and groups, it's actually what we call the structural time series models. The ad stocks are again the same, geometric, binomial, saturation is Hill. What it does additionally is it is a hierarchical model. The two things that stands out for the Google MMM, the first is that hierarchical, which means that not only can you build at a national level, you can also have regional or geographic level builds. So it uses a geo-level kind of a data or some substrata level of the data. And secondly, Google's MMM is the only one that actually allows you to directly optimize two of the things we do in marketing, which is called reach and frequency. Most other MMMs will say, how much should you spend, right? But in real life, that spend is spent in audience targeting, in special publishing platforms and this and that. So Google's actually allows the model to not only give us sales, spend data or impressions data, which is typical of MMMs, it actually allows you to say how many people did this reach, how many people does, how frequent was the reach of these people. So that's really pretty powerful. And then I do list the PyMC marketing world. I will honestly and candidly admit that when it comes to having a code base that you can run it, this is one of the most flexibles that we have found. And so for our scaling purposes, we do use a lot of it. It is hierarchical. It even has time varying parameters because in a modeling, you just cannot assume that throughout the year, the returns stayed the same, right? The marketing returns can be a certain value at one part of the year, and it can be a totally different value when you're running your ads during holiday or something else. So having mechanisms in the model that allows you to pulse the coefficients differently at different points in time, that's the time varying parameter model. So open source solution, which gives you a lot of flexibility in you can do hierarchical modeling, you can do time varying parameters model. They are a little limited in their ad stock, but honestly, it doesn't matter. Saturation, they use logistic. I think they're always, all of these, they're constant products that are being developed by their core contributors, and new features, new releases happen all of the time. As I said, we use the PyMC for scale and speed, but honestly, we leverage all of them because there's nothing as good as a data scientist to know you really got the inference correct, and so take more of the methods with the same data, be confident in your results, yeah. Acceptance model fits all of that, ease, interpretability, I talked about it, okay. Methods, testing, so anything in marketing is always not just the MMMs, but a thing that goes hand in hand with MMMs is the testing. These slides are, the general testing as applied to the marketing world. Everybody knows the line that the golden standard for causal inference is actually randomized controlled test, But the one thing we always say is that only works if you have more or less an homogeneous population and you can randomly assign, I think when RCTs are not always feasible, that's where we begin to get the problem and we have to start looking into quasi-experimental designs. One of the things that you will hear when it comes to the quasi-experiments is something called the counterfactual, right? The counterfactual is basically your test group and how would the test group have behaved if the treatment had not been given to that group. So it's the whole notion of testing is you have a control group and you're a treatment group, and the treatment group is the one that's getting all of the marketing treatments. The counterfactual are different ways of methods to say what would have been that path if it had not been given the treatment, right? And so the lift in a study then becomes the difference between what your actual treatment group's path is and what the counterfactual is. And we study the relationship between the control group and the test group in the pre-test period, and that relationship becomes how you formulate the counterfactual in the test period. Because counterfactual is not something you actually get to observe, right? It's not observational data. It is what would it have been in that circumstance. I think Samantha, if anybody heard the talk, personalization, she was talking about synthetic controls. Synthetic controls are you have all of this. And the classic example in marketing is the data, right? The geo level data. None of my geos are homogeneous, right? You could try to do your best job of pairing, geos into a test group and a control group, but sometimes even that's not possible. So this is where synthetic controls come up. You have one test market, say New York, and LA, which can be its counterpart, is not available. Then you use something called the synthetic control methods, which is basically in weighing of a lot of other geos to become the control group for your test group. Very quickly, I just listed what we have in open source solutions when it comes to test, There are many, many methods, everything from difference in differences to regression, discontinuity, kink design, you name it. But within the open source, again, PyMC leads with the Python code base, for causal pi. You can have actually all of these designs at the left and you can use it. For the R programmers, there is GeoLift by Meta, which is the version of the synthetic controls that I was talking about. There is GeoExperiments Research by Google, which is what they would promote and say use with your Meridian. And there's Causal Impacts by Google, which is another Bayesian time series modeling technique to predict the counterfactual. Uber also has its two-sided marketplace testing, that goes in parallel with Orbit. Point before I wrap up this section on these usual methods is that they are used in conjunction. Testing at any time is something that you can only do in a given moment in time. But MMMs are inferences that are over a longer period of time. So please do not ever take a test results and directly apply it to an MMM. There's a mechanism by which you can have to understand the flow of the effects over time and bring it that way. Very quickly, and I think I'm short on time too, so I must have spoken too much on the first few slides. Okay, this is an industry need. Everybody needs to know how their brand is growing, right? So it's if you're Nike in the market, if I say Nike, everybody remembers Nike because that's Nike as a brand is established, right? So all brands need to know how are they doing with their brand marketing over time. So in marketing, there's a short term, like you say, hey, I need shoes, and you just typed Google, and it showed you this Nike, there's Adidas, there's somebody else. We call that performance marketing, because that immediately takes you to the conversion of the sale point. But growing a brand over time is very high-level advertising and marketing. That has to be paced out. And one of the bigger industry questions they have is like, how do I know I'm doing the right marketing that will make my brand grow over time? Without going into too much details, this is a far more sophisticated model that you have to do. There's a short term that you have to tease out and a long term that you have to tease out. And the credit here goes to Dr. Peter Kane. He's from Oxford. You can look him up. But he really revolutionized or proposed like the using of what is known as the vector autoregression models, which is not just one time series at a time, but it's multiple time series that can be tracked over time and brought back to say, how is something today affecting something, in the future, when that something can be multiple metrics of the same thing happening. We're in a conference on AI, so this is Google's paper as of 2025, and I think this is revolutionary. Caveat, I haven't tried it yet, this is new learning yet, but what they came up with is a transformer-based neural network approach to MMM. What the biggest discovery for me in this was the use of the embeddings. So traditional MMMs can only take in scalar inputs, right? How much did you spend? How many impressions did somebody see of that advertisement? This is the first time we have a model coming onto the market that actually allows you to scrutinize the creative itself. So your video, your text, your picture can be an input into the model, and the way that they empower it is by transforming all of that into embedding. So the other thing NNNs does is that they speak to a lot of interactions, they'll pick up, because it's so good at picking up patterns, they'll pick up interactions that exist across the channels, which is not normally possible. You have to sit and hypothesize, is YouTube affecting paid search or this, and you have to do lots of causal diagrams and all. This is where NNNs also shine. They can quickly pick up and so, hey, I see something in the data, right? But it is at the end of the day a black box kind of a thing. Very quickly, data. In the interest of time, without going through anything, I will say we use the word party a lot when it comes to data, because there's first party, second party, third party, depending on what's gated, who's responsible, and who's paying whom for it. Some of them are user level data, and some of them are aggregated across the census and all of that. I have a picture of data platform that my company gives as part of its MarTech talk, but one of the biggest benefit that anybody can give in the world of data is this unified data, because marketing data is voluminous, but it's hugely fragmented. I do want to take a moment to talk about how big digital platforms like Amazon, Walmart, Target, Chewy, they're changing, the way of how we work with data. And that's because, they are the places, lots of people, I'll pick up on the example of Amazon, nobody really goes to Google anymore and searches. People who are who know Amazon actually will go to the Amazon website and start their searching for a product, right? So retail media network becomes very important, because as the consumers come very close to their place of purchase, how would you influence with marketing and advertising on those areas? So retail media enables brands to reach shoppers directly at the point of purchase, leveraging retailer data to target audience, et cetera, et cetera. This is very new development, but Amazon just released something called the clean room. So instead of you bringing the data out of the Amazon systems, this is they will give you the right access to the data, you bring your methods into the clean room. So there's a whole setup and ecosystem that is being developed. Previously, we would have to bring the data down to where we would build the models. It's a reverse now. The data exists somewhere, you bring your models to that data. Finally, this is my semi-last slide, I'm at an AI conference. The famous quote I have is from somebody I really admire a lot, that's Hadley Wickham, Chief Data Scientist of Posit, formerly RStudio. And he said, LLMs make the cost of trying so low that you attempt things you'd normally postpone, avoid, or never get around to. And I really believe that, because this year, as our team leaned in, the first thing we did was to basically put all our research documents that we have to read manually into these ChatGPTs, and they summarized everything for us. So I do think they help us learn a lot faster. They're interactive, like a tutor. I've had sessions like, you're telling me this, show me your reasoning for it, So that's to avoid the hallucination part. Coding assistance, this is huge. GitHub Copilot is what we use. Inline completion, blank idea, give it, and it would. I really want to talk about the IDs and the AIs that are empowered in the interactive development environments. Positron is one of my favorites, The difference in between a ChatGPT and in an IDE is an IDE has all the context of your data. You have everything in that, so it picks up, and the intelligence actually works faster and much better there. Experiment quicker, and of course, we are in the world of agents, we talk agents, and I've already seen, agents are built for build the MMM, ask a boatload of questions around it, this and that. It usually requires a multi-agent orchestration because you have to do the EDM module and this module and that module. As with anything AI, I think I pointed out, most people don't think about security. They're so eager to use, the vibe coding or something. They're not sure who is getting to see the data. And for an agency company, that becomes very, very important because we are the steward of the data that the client gives us. Bias, who am I not thinking of? What am I not thinking of? As it is, AI has its bias, and I have a personal opinion that unless we are watching, we're going to confound it with the agents that we create next for all the predictive and the prescriptive jobs. Finally, this is Ovative Group. This is where I work. This is the background, the big stage on which I get to do all of the things that I shared with you. Its mission is to transform how marketing success is measured, focusing on driving measurable impact in terms of revenue, customers, and brand equity. So if you remember, MMMs are about sales, new to brand, this is how we work it, and that's why I have to lean in on all of those research. I really like the company. The values are genuine, driven, inclusive, engaged, and accountable. And on the right-hand side is my short summary of what do I do on most days, So I'm dabbling in analytics and methods. I am understanding the domain of how all of these new developments in marketing, how is my data and everything, my methods applying there. Data awareness, nobody talks about data modeler's job, but I think data modeling should be its own job. And this is not about using data in a model, but how should you think about your data collection and data for downstream analytic purposes. Any day, we begin once with a model, trying to learn about it in a very ad hoc context. As I said, we are strategic projects, then I have to look at all the other parts of data science that allows me to make it a scaled offering that then goes into the product pipelines. Strategic partnerships, very blessed, Google, Meta, Amazon, PyMC, to name a few. And this is what I want to end on, When you're working with open source, you're not working alone. You're part of a community of methodologies. You're all working together to improve the methods across the globe. I have a team member that actually just contributed, so they're constantly contributing to these open source packages. And that's it. Thank you. Thank you. They kept on saying you should not be speaking too much about your company in the conference. I'm glad you said that. So I'm sorry, I might have not left too much time for questions, but we have a small group, so questions. Okay.
Question from our online audience.
Perfect.
Can MMM provide granular insights within a partner, like campaign-level performance, or is it typically aggregated at the partner level?
It is very much aggregated at the partner level, but what you do is you combine an MMM with something that's known as MTA, multi-touch attribution, and also all your platform analytics. They must all be trending and speaking of the same thing. So MMM is very high aggregated because you cannot have privacy level data in an MMM. It's not a user level thing. But you can then, MTA is all about tracking. You have to track. You can pair it with MTA at that time to say, how did exactly this campaign perform in that? I hope that answers the question. Yeah.
Hey, Koel, great presentation. Thank you for this. We are in an agentic AI era, Gen AI era, that since morning we have been listening to many AI presentations, so this is quite refreshing. Change of scenery. So thank you for that. So you have shown us that there are many different open source libraries. Which of those did you use? And if you use them, what kind of algorithms do you think are best for MMM? So you talked about ridge regression, right?
Yeah.
And then you showed about transformer as well. It's like a very wide range.
Absolutely.
So which one would you choose? And does explainability matter to you in your job when you apply this?
Yes. So most of the times I would choose something that is very well mature and well used. So if you looked at my LinkedIn communities, it's all about opinions about how does Robin compare with Meridian, how does it compare with PyMC, because this is open source, right? And so people are talking methods. So that which has been trial and tested and which I can understand at an explainable level, that is what I would choose, so like that. Doesn't matter if you're like ridge regressions, the way Robin implements itself, if you run ample number of iterations across the hyperparameter, you're probably doing something what a Bayesian would do, right? Like anchor on certain priors and then, like pulse for how wide the thing can do. So I go, and plus we are agency company, right? So our client coming in might say, I like Meridian, you've got to use that. So we keep the capacity. I use all, like in that. Neural nets is new, and one, it's black box. One, the skill set's not there where I just lucked out with having a computer scientist who kind of helped me understand what's going on. But we don't have trained people to do a lot of that, right? So it is new, it is still a black box, it has a lot of promise, but I haven't actually experimented with it. The first run did not show much, but that's not fault of the neural nets, fault of how are we applying it, right, compared to the traditional.
So even if it shows the best results possible, which I think it is the case with the transformer-based models, so even if it shows you best results, would you accept it? Because
there's to your point, the interpretability, the black box, so like if you can explain what is happening, and oftentimes what is happening can be backed up by your other hypothesis testing in other places, absolutely, it is just a huge thing, like where am I going to do it? Like because we have GCP as Google Cloud, and I could go to the AI Vertex and this, think of it, even generating the embeddings of a YouTube video, only Google has it. So I have to take their method and I have to generate the embeddings because the open source is not there yet in terms of how would you do this, like changes and all of that. Open source is there with the methods. Once you have the data, what are the different methods that you can use? So to your point, till I'm confident that the method is working across multiple data sets, and it's really something I can explain back to the client, it is still an experiment that we are doing, still learning. Nobody's asking for like neural network MMMs yet. I mean, I only know it because I'm tracking the research community, but not a single client has asked for it yet.
Got it. My last question. So do you see yourself favoring ridge regression or the classic regression algorithms over neural networks just because these are more explainable, even though the neural networks would give you fantastic results? Do you see yourself
There's
favoring
no guarantee it can. It might, but that's the experiment, right? It might. I mean, the reason I'm interested is because, as I said, it can do something that traditional MMMs cannot do, like campaign. We talked about it. How would you measure a campaign, It's not possible to measure a campaign at the creative level in a traditional MMM. That's not how those algorithms work. So it has the promise. And if we were to go for solutions that can simultaneously not only speak to how are your different channels working, but how is your channel performance is a function of the creative that you're putting in your advertising. How can that be? Tremendous promise. But the ecosystem is not there for easy experiment. As I said, the only place you can run it is right now AI Vertex on Google. It's not something I can run elsewhere. Even if it's a small data set, even if I have the right architecture for it. So again, it has to be acceptance of the methods. And again, Google is big. If they can prove this and if they can put it into their publishing systems, who are we to say should we use it or not? It becomes mainstream, right? All advertisers and measurement groups are using it because they've enabled easy adoption at that time.
Thank you so much.
Yeah.
Anyone else want to ask a question?
So
Oh, we have another one from
So
online.
when it comes to the usage of AI coding assistant, so I do believe that for experienced developers, it would increase their productivity, like generating redundant code, and like they would be able to figure out if the responses are hallucinated. So when it comes to like novice developers or the developers who are brand new to that tool, so I believe that that would restrict their analytical thinking and in terms of like generating code. So I do believe that that would kind of hinder their abilities on that. So going forward, how do you see that would change the future of the developers?
Yeah.
Yeah.
Actually, there's a very good article somebody wrote, and it resonated with me. We put AI in the hand of all developers, but right now it's the senior engineering managers who have tons of experience in coding and tools who lead with that, you know? And so, you know, vibe coding is there. You can go in with natural language and you can get any code. But we don't ask everybody to use that, right? The first person who's gonna like test out whether the vibe coding of a tool or a system is working is a person who's actually coded and has tons of experience, you know? So it's the senior engineering managers, data science managers, leaders who have ton of experience doing it that lead that. Very, very true. Like as somebody who comes in and who's not deep in the experience and all of that, how will they think through? Very true. So that's why we partner experience with like new talent, but everybody's got to do the work, and that's the productivity unlock, right? So guardrails, you put the guardrails, you know. So yes, I mean, like there's so many tools that can say, oh, just ask something and you will get that. But we haven't enabled that for the entire company, because who knows? It's like, who will judge whether that was the right answer or not? So for example, the positron ID, I call it, you can type in and it will right away generate and show you the code, you know. And so if you have the experience, you can say, yeah, I accept that code. If you hit the accept button, only then the code flows into your line. If you don't, you said, no, this is not right, it will go back and regenerate it. So guardrails and checks. So it's not a blatant thing like, yes, everybody go use, but the more the checks, the more the system matures and the less the system hallucinates, the more stable it becomes for you to risk it in the hand of a person who doesn't know. Even if they don't know coding, let's say, they know what the outcome should be. So experience again, like my ROI here cannot be this, right? So if the code returns something different, they ask you the question, how? Tell me. So yes, we have to balance experience at this current stage of evolution with like all the new tools coming online.
Thank you.
One more question.
All right, final question here from the online crowd. How can MMM be used to measure performance across different stages of the marketing funnel, especially when the underlying data is relatively flat to understand?
Different stages of the marketing funnel, okay. That is the intent of your marketing. That's how. So this is where the cognitive understanding comes in and not just flat. So I have seen in MMMs where the spend on the impression, like for example, YouTube, that is strictly like kind of like upper funnel. So this is the cognitive and the knowledge of the person then says, where is the spend on the impressions, And is it a more of an upper funnel experience? Is it a more of a lower funnel experience? Sometimes a channel can be all three levels of the funnel. In fact, in brand marketing, when we do the work, the word funnel is not at all liked because every channel is believed to be driving the front. So for the audience in the group, upper funnel is like those high-level TV, online video, which is not the one that's right away driving to conversion on the sales, but which is influencing the awareness of your brand and your propensity to buy that product. There's the middle funnel and the lower funnel. The lower funnel is literally, I type shoes, they showed me Nike, I went to Nike and I bought it. So that's what we call performance marketing. So the question is like, how would you can MMM explain all parts of it? I've seen many creative ways of actually leveraging an MMM. You basically say, this channel is upper funnel, this channel is middle, do not agree with that philosophy, you know. So I think it's more about understanding your data and what it's telling you and how to orchestrate it, and then using your MMM effectively, you know. So this is where an out-of-box solution will not just give you the answer, because you have to think through, what am I putting in the data? What are the markers in the data? What am I call it conceptually? What is upper funnel, lower funnel? And speak to it. So my comment about you just can't use open source by itself, but you need expertise to experience to get the most out of it is exactly along the lines.
Right. Before I ask you to give it up for Koel Ghosh, I have one announcement. There is a networking reception following this conference, which is now wrapping up, at Malcolm Yards in Minneapolis. It's very close to the university. I can't tell you the address, but if you Google Malcolm Yards, you'll find it. It's a pretty cool place. Now, please join me in thanking Koel Ghosh from Ovative Group. Okay.